Yesterday we simplified rational expressions, multiplied rational expressions, and divided rational expressions.
Is that going to be harder?
Depends on you. Okay. Today we are going to add and subtract rational expressions with different denominators. Okay, remember to add or subtract fractions, they have to have the same denominator, common denominator. So we have to create that common denominator. It's easiest to use the least common multiple of the denominators as a common denominator. Least common multiple of the denominators as a common denominator. Common denominator. Okay, I decided that example 2, it's really just like extra practice of what you're going to use in the problem, and I don't think you need it. So, hopefully I'm right, and we are going to skip that. So that's why you do not have to do number 4 through 7 on your homework. So those people who are absent, either hopefully they have good friends that are going to tell them they don't have to do 4 through 7, or they're going to watch the video. Like Paul. We'll see what Paul does. Okay.
Wait, is he still doing all this? Oh, he's back. He wants something.
Yeah. So, we're going to add these rational expressions. Obviously, they have different denominators. So, we have to break the denominators down, figure out the difference between them, kind of fix them to make them look alike, and then we'll put it all together. So, I've got those steps on the side, just said a little differently. So, first we have to factor the denominators, and I didn't really leave you a whole lot of room. So, a little bit, yeah. So we're going to start by factoring this one, and I'm going to do it over here so I have room. What goes in the top of my x?
4.
What goes in the bottom? Okay, 5. What numbers multiply to get 4, add to get 5? 4 and 1. Okay, so then our little fraction things would be 4 over 1 and 1 over 1. So what are the actual factors? X plus 4 and x plus 1. And the 1 is still your numerator. Okay, now for the next one, that one's not quadratic, but we can still find something common between 3x and 3. What's common? 3. So we're going to bring a 3 out to the front, which is, you should have done that on some homework assignments. Homework problems yesterday. So what would be left if you took 3 out of that? X plus 1. Because you took the 3 out of that, which left just x. 3 out of that leaves a 1. And then 5x is still on top. Okay, now this is the part where we make the common denominators, which I wrote identify for multiplication. That's kind of vague. What I mean is, what is each denominator missing that the other one has? Leave some space to where you can write something in after each of them. So what does the second denominator have that the first one doesn't?
3.
A 3. So we need to multiply the first one by 3. If we multiply the bottom by 3, we have to multiply the top also by 3. Okay, what does the first denominator have that the second one doesn't? X plus 4. So multiply numerator and denominator by x plus 4.
And then we can just cancel them out.
That would send us backwards, back to where we started. So we don't want to do that. Okay, so now simplify each fraction. So the first one, what is 1 times 3 on top? 3 over, let's see, we were just going to have 3 times x plus 4 times x plus 1. And then for the next one, we can distribute this 5. 5. Yep, 5x plus 20.
Can we distribute that 3?
What happened to the X on top?
They got distributed.
Oh,
It's supposed to be like 5
yeah, you're right.
squared.
That's supposed to be an x right there. Okay, yeah, so 5x squared times x. Okay, I forgot to write this x right here. Whoops, but now it's there. So 5x times x is 5x squared. 5x times 4 is 20x. And then the denominator is the exact same as the first one, which is our goal.
So,
So now the last step is to write it as one fraction. So you know your denominator, 3 times x plus 4 times x plus 1. And numerator, it's addition, so everything's just added, but you have to write it in the correct order. So what comes first?
5x squared.
And then
20x plus 2.
20x, and then the 3. And there's your answer. Better or worse than yesterday?
Where's-
Sometimes you have to factor it again.
Where's-
Okay, we learned that in chapter 5, and I told y'all we'd be using it over and over and over again.
Worse.
Okay then, yay! Y'all are so positive.
Well, they were gonna fail.
Okay, any questions before we do the subtraction one? The subtraction, you do it the exact same, just this last step will be subtracting. Okay, so good practice here.
Perfect square.
It is a perfect square.
No, like
Oh.
circle the answer.
Oh.
It's perfect, like almost.
Almost.
A rectangle, whatever.
Perfect rectangle. Okay,
Please square.
glad that's on the video. So start out by factoring your denominators. So here, first thing to always look at is there something common between the terms in the bottom? What's common?
5 on 5.
A 5. So let me zoom in a little more. Sorry, we did that in chapter 5. Okay.
I remember.
So if we take out a 5, blue. Okay. If we take out a 5, what would be left?
Y squared minus y squared.
Y squared minus, what's
Like
125 divided by 5?
50. 6.
How many quarters are in $1.25? 25. 5. There, 5. Okay. Now,
What was that?
your favorite part. We got to factor that y squared minus 25. What's a times c?
Negative 25.
Negative 25.
What is a 0?
B is 0, so that goes in the bottom. So what two numbers multiply to get negative 25, add to get 0?
Negative 5 and 5.
Negative 5 and 5.
X minus 5, X plus 5.
Very good, because you'll have negative 5 over 1x. Oh, nope, not x. Y.
Wow.
And then 5 over 1y. Okay, so that gives us, back over here, 5 times y minus 5 times y plus 5. Okay, stay focused. Don't lose it. If you're not writing anything down, then you should really stay focused.
I would, but my pen ran out of ink, so.
Bert, you got another pen?
That'd be nice.
I'll get you a blue one if you want.
Who's gonna win? All right, so what is the numerator of the top? I mean, the first one. 7y. Okay. Now, the second one, look at the bottom. Anything common to bring out to the front?
3.
So what does that leave you with?
Why are we doing
Y
something?
plus 5.
Say what?
Never mind.
4 plus Y plus
4 over
5. What?
3 times y plus 5. Okay.
You have to show that you brought it out. No way. Right?
Huh?
You have to show that you brought it out.
I mean, it has to still be there. You didn't, like, move it to the other side. It's just still there. Okay, so now, what? Ooh. Let me write them out with a little more space. You can combine steps if you want, but I just didn't leave enough space. What does the second one have that the first one doesn't? 3. We're looking at the denominators. Multiply the bottom by 3 and the top by 3.
So would you have to multiply the other side by 5?
By 5, what else is missing?
Y minus 5.
Y minus 5. So you got to do it by everything. Woohoo! All right, so let's simplify here. Let's see. What's 7y times 3? 21y. On the denominator, I'm going to go ahead and multiply 5 and 3 together because that's pretty simple, 15. But I'm going to leave my y minus 5 and y plus 5 in parentheses.
And 20.
I'll do 20 times y minus 5 and then take a little extra step here to finish simplifying that. So if you distribute that 20 in there, what does that give you? 20y minus 100. Mark that out. Okay. So, last step is to put it into one fraction. So I know my denominator, 15 times y minus 5 times y plus 5.
We got 19Y minus 1.
Okay. Watch out here, because this is the difference between addition and subtraction. This minus sign, it goes with a 20 and with a minus 100. So what is 21y minus 20y?
Y.
Just one plain y. And then what's,
Wait, what?
okay, 21y minus 20y. So just y. Okay, and then what's minus times minus 100?
Plus.
Plus 100. Ta-da!
Stupid.
Yep. Any questions about adding or subtracting and finding common denominators? There is a back. Yep. So, a complex fraction is a fraction that has a fraction in its numerator or denominator or in both. So it's fraction within a fraction. That
Yep, definitely.
complex fraction.
Can I, like, bribe you and not do this?
No.
Some people accept that.
I mean, I'd accept whatever, like Sour Patch Kids or whatever you're gonna give me, but I wouldn't necessarily not let you do it. No. Okay. So here is a fraction within a fraction. That one's not that bad.
Yeah, but look at the last one.
I know. Gross. Okay. So this sentence here tells you what to do, but I find it very confusing. It'll be less confusing once we've actually done it. So there are two different methods to simplify complex fractions. We're going to do both. Write them both down, and then you can figure out which one you like better. Okay, and use that one. Or which one you like the least. Dislike the least. Yeah. Okay, so the first method is, I'm going to call it least common denominator. Step one is to find the least common denominator. Okay, so the denominator of the top is x, and the denominator of the bottom is y. So if you were going to combine them into one fraction, what would be the common denominator? xy. Okay, that one's not bad. So our least common denominator is xy. Now, step two is multiply top and bottom by your least common denominator, LCD. So I'm just going to rewrite the problem here. And I'm going to put the numerator in parentheses and the denominator in parentheses. Just to kind of help my visual. And then I'm going to multiply the top by xy and the bottom by xy. What do you think we should do on the top?
Cancel an X.
No. Distribute. Perfecto. And you're going to distribute on the bottom too. So basically just every term in that problem is going to get an xy in its numerator. So that will look like, what's 1 times xy? Xy still has an x in the denominator. Plus 3 times xy is just 3xy. Okay, so that's the top. What will the bottom look like?
5x over
5xy.
Mm-hmm.
Over y.
Plus
4x.
4xy. Together, you'll make a great mathematician. All right. So very close to being done. Step 3 is to simplify. What can we do to simplify this? Somebody's got to see it.
x, y.
Cancel stuff out. What can cancel?
We're just left where we were.
Hold on. Look at right here. What can cancel?
X.
Ooh, the denominator is gone. What about in the bottom? The y's. So our answer will be y plus 3xy over 5x. Very good.
What's your answer?
That's your answer.
Still
I like that method better, but you can choose. I'm going to still show you the other one.
Is it like, is it easier?
Why don't we just
It's just different.
go to the homework now?
No. I'll show you the other one. Okay. So the other one, it's approaching it as, it's a division problem of fractions. So how do you, well, hold on, I'm getting ahead of myself. Let me slow down a minute. Okay. Let me make sure I say this right. First of all, I'm going to write it as a division problem instead of as a fraction. So that'll look like 1 over x plus 3 divided by, I'm going to use my actual division sign, 5 over y plus 4. Okay, so step 1, we're gonna find least common denominator for each part. So over here, what is the common denominator in just this part?
X.
X. So that 3 does not have an x below it, so we need to give it an x below it. So it'd be x, we're multiplying by x over x, right? So that would give us,
Where'd you get the X on top?
well, if I multiply it on bottom, then I have to multiply it on top. Same thing that we did on the front. That gives us 1 plus 3x over x. Is it with a common denominator? I'm just combining those into one fraction.
So
What would the next one
the
be?
1 cancels out?
5 over y plus 4x over 8. Or y over y.
Y over y. So I'll go backwards. Hold on. So the 4 is going to get multiplied by y over y. What were you asking about the 1, Austin?
Yeah.
Got it. Have I lost anybody yet? Yes? Okay.
Why isn't there a 2x on the bottom of that first one?
Because it's adding fractions, and when you add fractions, they just keep the same denominator.
Got it.
Good question. If we were multiplying, well, then it'd be x squared, but
That'd be x.
yeah. Okay, now what do you think we should do since we're dividing fractions?
Get rid of those x's.
No.
Use the x block thing.
No. What did we do yesterday when we were supposed to divide? We didn't actually divide. Multiply by reciprocal. Do any of y'all call it, say, keep, change, flip? No? That was just classes last year. They said you keep that one, you change the sign so it becomes multiplication, and then you flip the last one. I don't know. So multiply by reciprocal. I don't know which teacher did that, but evidently they had it and you didn't.
Miss Kelly, I think.
I remember hearing.
I
She
didn't know if it was
didn't have
Kelly.
Miss Kelly. Maybe the first class said Miss Kelly.
Those whoever that teacher was.
I'd never heard that until last year, I think. So that'll look like 1 plus 3x over x
Or was it Miss Hershey?
times y over 5 plus 4y. If you want to, it might help you go ahead and put those two-term parts in parentheses. And we're just going to multiply across, which means we're going to distribute the y to everything on top and the x to everything on bottom, and then we will be done. So step 3 is simplify. All right, so Alicia, what will I get on top when I distribute?
You're gonna get, wait, for that one.
Yeah, for this part.
Okay, you're gonna do that 1 plus 3y, or x.
Yeah, y plus 3xy. All right, and let's see, Clark,
What do you want from me?
what are we gonna get on the bottom, the denominator? Whoops.
5x plus 4xy.
Correct. That should be the exact same answer we got using the other method.
No.
Yes, it is.
Which one do you like better?
The first
Or dislike less? The first one? I like the first one better. The first one's just a little trickier because you have to, to find the least common denominator of the whole thing, whereas this one you like dealt with a half at a time. I think that's kind of the difference. All right, you have either 12 or 13 problems. No, 13 problems. You can do it.
No.